Hi, it's Kim Nelson with the Jewelry Design Department at FIT. I'm doing a video here this morning, just going to go along with a project that I actually am working with. I figure it might be interesting to show something very basic, at least aesthetically basic. Engineering, it might turn out being a little complicated. I'm going to make a hollow box form, and those are my dimensions. Now, Rhino has tools that would allow me to just come in and make that as a solid. That's not my most comfortable way of working, so that is not how it will be done. I'm trying to decide which orientation I want for this. Okay, I'll go with the 12 millimeters. And then I'll simply extrude out the box dimension, which is 8 millimeters. Solid, yes. Oh, except it's both sides, so 4. So that's essentially the box form that I'm working with. Okay, sorry, I needed to pause that for a moment. This box is going to have a grooved detail on every face. That groove will begin 0.6 of a millimeter from the edge. So I need to draw that information in. So I just stole the border, the outline of the edge there. I'm going to offset it 0.6 and offset that 0.35. And I can just copy that to the bottom. So I've got those two faces. Now I'll do it for the front. I did it pretty quickly before. I'll go through it a little bit more verbally. I'm going to extract the surface, copy option yes, going to duplicate border, copy the border to the clipboard outside of Windows, undo, undo, and then paste in that line. And the same two dimensions, 0.6 and 0.35. And once again, copy that over to the other side. This is important because the challenge with this little box is I need to hollow it out. So it needs to be a two-part assembly. However, that 0.6 of a millimeter that I have is insufficient to be able to get what I want, basically. And that makes it a challenge as to how to assemble this piece, because if I make it a mitered joint right at the corner, the chance that that's going to fit just so is not great. But it looks like that is going to be my very best option. So first I'm going to actually make these into a groove into the top. I would think that 0.6 of a millimeter would certainly be sufficient. I would think 0.5 millimeter would be sufficient. So for manufacturability, I'd probably bring this to some kind of a point in the bottom for cleaning purposes, but this is just for to show a client, so to have a conversation. So there's really no, I want to do that again, the solid option. And I may as well mirror that over. So that I have it on both sides. Seems to believe I have two extrusions there. Okay. Which makes me wonder if I mirrored the wrong thing. I believe I did. I believe I mirrored the parent block. There we go. Solid difference. Half a millimeter is quite deep. I think I will go to 4/10. And then mirror that. And Boolean, take a look. I could have done those both at once, but that's fine. Same thing here. Mirror that over. And Boolean difference. So I've got that. I don't need any of these curves anymore. I don't want to have a cluttered scene, so I'm going to group those and put them in storage. So I am going to have to miter this corner. So first thing I'm going to do is I am going to do an offset box on the inside of this. So extract surface, copy equals yes, surface untrim, double check, yep, front, I'll just move it down 1 millimeter. Actually, this is a pretty small box. I can get by with 0.8 or even, for weight purposes, 0.75. Same thing here. And yes, I could have used an offset surface. There are several ways I could have done this. But this makes the most sense to me this morning. Just making copies, trimming it around. Now, since this doesn't break outside of the box, it's doubtful that it will Boolean. Let's find out. My instincts tell me it will simply not do it. I'm going to save before I go any further. You ask Rhino to do something crazy with a Boolean. Yeah, it doesn't intersect. It has to stick out. That's what I figured. But it is good to have because we're about to use it. So, how to get the same effect. I would like to have a 45-degree miter here. all the way around. That's what I want. So I'm going to copy that out to clipboard. I'm going to draw me a curve, both sides option, and I'll constrain it to 45 degrees, just like so. And then I will extrude that straight out. I want to get a look at it. Okay, that's what it looked strange to me. I thought maybe I had project on, but I didn't, so I couldn't figure out, obviously, got lost in space. So, there, that's better. Just going to trim these up into a single cutting tool. Check the direction. I want to keep what's on top. Cool. So now I have that. Repeat the process. Extrude. Trim. Join. Solid difference. Should check my direction. Yep, it's good. And then one more. Delete input. No, I don't want to lose my block. So I've got that. Put these on a different layer. And I'm going to paste back in my original box. And I'm going to paste it in again. And then I'm going to hide it, just in case my clipboard gets cluttered and somehow I end up taking that out, which is not something I want to do. Okay, so now I'm going to do it for the front piece here. The same curve should work just fine. Oh, that's interesting. I got my pick point wrong. There we go. Trim. Join. Direction. Yeah, see, that is wrong. Solid difference. And once again, this should work. all I'm doing is mirroring the extrusions in different directions before I make them into a cutting tool. Join, direction. And actually, that is not right. Good thing I stopped myself. Time to do some thinking. What I want is I want a surface to bevel inward from here. Sometimes your brain does not want to cooperate with you. And when that happens, the best thing to do is take the easy way out. Going to untrim. And I'm going to rotate at 45 degrees. Or minus 45 degrees, as the case may be. There we go. That's going to do what I want. And that was just an easier way for me to make sense of it. Check my directions. And difference. Here's a 50% chance this will fail because it comes right to the corner, the way it does, but Rhino actually accepted it. And then solid difference. Mirror it. So now, I have the panels of my box coming together. The last thing I need is the end caps. So, paste. There's back my original box. And do some extrusions. Mirror. Trim. Join. Check the direction. Solid difference. Join, check direction, solid difference, solid difference. Put that block in storage now, don't need it. Mirror it over and get rid of the extra curves. And this is my box. The reason I made this box is to discuss with my client how he might want to assemble this unit. And I'm going to submit the idea that there should be 3 panels going around this way and then 2 panels across the top. So I'm going to put that together. It's very possible that the Booleans will do this for me. I'll try. Before I do, I'll copy, paste, group, put it in storage. Just hygiene. They're what they call coincidental surfaces. These surfaces are in the exact same place, but they're geometric. Normally a coincidental surface will make Rhino cough up a hairball, but because they're geometric at this clean 45-degree angle, sometimes you can get away with that. So let's see what happens. Yeah, that's good. That saved me some time. So there are those surfaces. Do the same thing here. Just putting a copy in storage. And union. And there we have it. Okay, we have the 2 components so that I can discuss how I think this assembly should be done. Now I need to set them up so that they are visible. So that it's clear to the client what I'm trying to achieve. There, just use grid snap, it's easier. So there we have it. So now what I need to do is I need to do a rendering of this for the client. To do that, I'm going to import a rendering environment. Turn off grid snap. I'm not going to want to have to monkey with this too much, so I am going to save the view. (34) just means 3/4 view in my world. Okay, and I'm going to assign some materials. I'll make that one silver. And I'll make this one gold. Just so it's easy to tell them apart. I may have moved that view. Just want to make sure I didn't. Okay. This should already have material assigned to it, so ray trace with neon. And usually about a minute is all that I need to get a rendering that makes sense. Unfortunately, the reflections are so harsh in here. not getting a good result. Just in case I want to pull that back up. Yeah, that is going to, because of the reflective nature of what's going on with this. Oh, it's my environment more than likely. So I didn't even think about that. Yeah, it's got a basic environment kicked in there. Yeah, that'll help. Still getting really, really harsh reflections, making it hard to really assess these things well. The reflections can be nice, but they can also be very difficult to deal with. Drop that reflectivity way down. Take the base color up. And we're going to do the same thing for the gold. Maybe not quite as, yeah, that's good. It is very bold to make these kinds of sweeping adjustments in Rhino with the neon renderer running. It taxes the memory quite a bit. And if I were doing this wisely, I would never make that mistake. But there we go. Give it a minute to render. It's at 23 seconds down here. I think that's sufficient.